Okay, welcome to our new unit on linear equations, and we're going to start off by talking about writing equations using symbols. So as I mentioned in class, this is going to be the perfect segue for those of you going into Algebra 1 next year, because you're going to start off with algebra. All right, and in class we went ahead and introduced the vocabulary you should know and vocabulary that will be used in this unit. And again, we obviously won't get through the whole unit, but know that this will continue next year. And I will also be giving this to you so you can look at it during the summer. All right, so we have two items here. The number 1,157 is the sum of the squares of two consecutive odd integers divided by the difference between the two consecutive odd integers. And then on the right-hand side, we have 1,157 is equal to the quantity of x squared plus the quantity of x plus 2 squared over the quantity of x plus 2 minus x. So the question is, how are these two related? Which representation do you prefer, and why? So would you rather write out math problems like the way on the left, or would you rather work with a math problem like is presented on the right? So go ahead and take a minute or two to answer that in your math journal. Okay, so again, no right or wrong answer, just something to think about as we talk about representing numeric statements. So a little bit of background. Using letters to represent numbers in mathematical statements was introduced by René Descartes in the 1600s. In that era, people used only words to describe mathematical statements, just like in the previous example on the left. Use of letters or symbols to represent numbers not only brought clarity to mathematical statements, it also expanded the horizons of mathematics. The reason we want to learn how to write mathematical statements using symbols is to save time and labor. Imagine having to write this sentence. The number 1,157 is the sum of the squares of two consecutive odd integers divided by the difference between the two consecutive odd integers. Then imagine having to write the subsequent sentences necessary to solve it. Compare that to let x represent the first odd integer, then 1,157 is equal to the fraction of the quantity of x squared plus the quantity of x plus 2 squared over, or divided by, the quantity of x plus 2 minus x. I think I'd like the second way better. So notice that x is just a number. No need to get scared or freaked out about the fact that we use letters to inside of mathematical statements. X is just a number. That means the square of x is also just a number, along with the square of the next odd integer and the difference between the numbers. So this is a symbolic statement about numbers. We've just replaced or are interchangeably using letters, in this case x, to just represent a number. But that is all it is. Writing in symbols is simpler than writing in words, as long as everyone involved is clear about what the symbols mean. So this lesson focuses on accurately transcribing written statements into mathematical symbols. When we write mathematical statements using letters, we say we are using symbolic language. All of the mathematical statements in this lesson are equations. Recall that an equation is a statement of equality between two expressions. Developing equations from written statements forms an important basis for problem solving and is one of the most vital parts of algebra. Throughout this module, there will be work with written statements and symbolic language. We'll work first with simple expressions, then with equations that gradually increase in complexity, and finally with systems of equations, which is more than one equation at a time. And essentially in Algebra 1, this is what you'll be doing all the time. So these next 5 examples are all going to be in your math journal. So make sure that you are copying these down and answering the questions that go with them. So we want to express the following statement using symbolic language. And our first statement is, a whole number has the property that when the square of half the number is subtracted from 5 times the number, we get back the number itself. Sounds like a bunch of gobbledygook, and luckily we do have symbolic language that we can translate this to. But again, it takes practice, so this might sound like it completely doesn't make sense, but when you break it down into its parts, as you will see in these next 5 examples, it does become a little bit clearer. All right, so what is the first step? Again, we have to define our variable or quantify our symbols, and we talked about that early in the year. So we are going to use x, and we're going to say let x be the whole number, because what we're talking about in the initial statement is a whole number has a property. So we're going to let x be our whole number. So using x to represent the whole number, we're going to write the square of half the number. So the square of half the number, which can be written actually in several different ways. So here is a square of half the number. Here is another way to write a square of half of the number, or a square of half the number, or in this case it's 1/4 of the number squared. So why are all of these correct? And I'm not going to give you the answer. This is something you need to take a look at. But why are all of these representations equal to themselves? This is the most direct interpretation, but why are all of these equal to this second term right here? All right, so now that we have one of these that we're going to pick, we're going to write the entire statement. A whole number has the property that when the square of half the number is subtracted from 5 times the number, we get back the number itself. All right, so we're obviously going to use this. Now we need to finish the rest of the statement. So see if you can match up what is happening. A whole number has the property that when the square of half the number, so they've elected to use this term, which was up here, the first one, is subtracted from 5 times the number. So this is being subtracted from 5 times the number. So 5 times x, or 5 times the number, minus this part right here. We get back the number itself, so equals the original number. So this would be one way to write this. Can you write that particular, hopefully you copied it down, can you write that particular statement in another form? So here is the original statement from the previous slide. Can you write this differently? Is there another way that you can write this? Well, here is another way you can write this. Compare these two. Why are they the same? Why is this statement the same as this statement? And again, why are these both correct? So you could write it like this, or you can write it like this. All right, and again, we're not solving these. We are just practicing transcribing statements into numeric or symbolic language. So let's do our next example. We want to express the following statement using symbolic language. Paulo has a certain amount of money. If he spends $6, then he has 1/4 of the original amount left. So again, the first thing we must do before we express this situation using symbols, we have to quantify the symbol that we are using. So we need to define our variables. We must decide what symbol we're going to use and state what it's going to represent. So this is our let statement. So we are going to, suppose we decide to use the symbol X again. We are going to let X be the amount of money Paulo had originally. Now, how do we show Paulo spending dollars using symbols? Well, we have to show that Paulo spent $6. So it would be some amount of money, we don't know what that is, but some number, minus 6. So that's the first part. How do we express he has 1/4 of the original amount? Well, we can express it as 1/4 of X. Remember that we don't express multiplication as 1/4 times X because it could be confusing. An X next to an X might make it look like it's X squared. So 1/4 X means 1/4 times X or 1/4 of X. And if you remember back to fractions, fraction of a fraction is the same as multiplying by fractions. All right, so now we're going to put the parts together to express Paulo has a certain amount of money. If he spends $6, then he has 1/4 of the original amount. And we're going to use X to represent the amount of money Paulo had originally. So it should look something like this. So the amount of money minus 6 is equal to 1/4 of the original amount. Can you write this in another form? So going back to our first example, is there another way you can write this? Take a second, try it out, and then continue and see if your form matches the form I'm going to present. All right, did you come up with something that looked like this? If not, compare these two and see how they are similar and how they are different. All right, example 3. We want to write the following statement using symbolic language. When a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. So again, the first step is to clearly state what we want our symbol to represent. If we choose the letter X, which is pretty popular, then we would say let X be the fraction of 57, because that is the number that is unknown to us in the written statement. So it's acceptable to use any letter to represent the unknown number, but regardless of which letter we use to symbolize the unknown number, we must clearly state what it means. This is called defining our variables, or again, from the beginning of the year, we also called it quantifying our symbols. The hardest part of transcription is figuring out exactly how to write the statement so that it is accurately represented in symbols. So that's why this takes a lot of practice. If you're not getting these right away, again, it is okay to be frustrated by this. It only comes through more practice of doing this. You can't get it in the first couple of steps. All right, so begin with the first part of the statement. When a fraction of 57 is taken away from 57. So how can we capture that information in symbols? And please do not get hung up on the word fraction. It doesn't necessarily mean that we're going to have a fraction. But remember, fraction in this case is part. When a part of 57 is taken away from 57. So it could be a fraction, it might not be a fraction, but in this case we're talking about a part that is less than 57. All right, so we can say 57 minus x, because a part is being taken away from 57. Again, this could be a fraction. It might not be a fraction, but it is a number. So now, how do we write 2/3 of 57? Well, that should be pretty easy. Again, we are trying to find 2/3 of 57. So we are multiplying 2/3 times 57, or again, we can drop the dot representing multiplication and just use parentheses. That is typically the more common and more acceptable way of showing multiplication. So 2/3 of 57. So, would it be accurate to write this? 57 minus x equals 2/3 times 57. Remember, go back to the original statement. Are we done? Well, your answer should have been no, because we are told that what remains exceeds 2/3 of 57 by 4. So we have a 4 that we have to deal with. So where does this 4 belong? What remains exceeds 2/3 of 57 by 4. Think about what the word exceed means in the context of the problem. Specifically, which is bigger, 57 minus x or 2/3 of 57? And how do you know this? Well, 57 minus x is bigger because 57 minus x exceeds 2/3 of 57 by 4. Okay, so this number is going to be bigger than this number, and the difference is going to be by 4. So that means that 57 minus x is 4 more than 2/3 of 57. So we know that 57 minus x is bigger than 2/3 of 57 by 4. What would make the two numbers equal? Well, we either need to subtract 4 from 57 minus x, or we need to add 4 to 2/3 of 57 to make them equal. So how are you going to show that in a numeric statement or a symbolic statement? So now if x is a fraction of 57, we could write the quantity of 57 minus x minus 4 is equal to 2/3 of 57, or you can write it as 57 minus x is equal to 2/3 of 57 plus 4. Which is correct? Or are they both correct? Well, they're both are correct because they both express the written statement accurately. Again, we can either subtract 4 or we can add 4. So either one of these statements is correct. So let's consider the transcription of the quantity of 57 minus x minus 2/3 times 57 is equal to 4. Ooh, can we say that? Is it an accurate transcription of the information in the written statement? So compare this to this to this. Well, the answer is correct, yes, because 57 minus x is bigger than 2/3 of 57 by 4. So that means the difference between the two numbers is 4. If we subtract the smaller number from the bigger number, we have a difference of 4, and that is what this version of the transcription shows. So you can write it in that format also. All right, example 4. We want to express the following statement using symbolic language. The sum of 3 consecutive integers is 372. Well, do the first step. Let x be the first integer. Okay, so we have consecutive integers. We don't know what the integer is. but we have at least one to start with, and that's going to be the first one. Again, if you want to choose a different letter than X because you're getting tired of using X, by all means, go ahead and do that. All right, so if we let X represent the first integer, what do we need to do to get the next consecutive integer? Well, if X is the first integer, we need to add 1 to X to get the next integer. Because if, let's say, the integer is 5, well, the next consecutive integer would be 6. How do we go from 5 to 6? Well, we have to get 1, or add 1 to it. So in symbols, the next integer would be X plus 1. Now that we've got the first and the second integer, what do we need to get the next consecutive integer? Well, we need to add 1 to that integer, or it's going to be X plus 1, which is the same as X plus 2. So now we can express the statement, the sum of 3 consecutive integers is 372. So we're going to add the first integer, the second integer, and the third integer. So it will look something like this. Here's our first integer, which was X. Here's our second integer, which was X plus 1. And here's our third integer, which is X plus 2. Or, if you don't like the parentheses here, you can write it all out. X plus 1 plus X plus 2 equals 372. Can you think of another way to express X plus 1 plus X plus 2 equals 372? All right, for example 5. We want to express the following statement using symbolic language. The sum of 3 consecutive odd integers is 93. Do the first step. You should be old hat at this point. So let X be the first integer. If we let X represent the first integer, what do we need to do to get to the next consecutive odd integer? So again, what would be an odd integer? Well, you can pick 5. Well, what would be the next odd integer? Well, that would be 7. Well, how do we get from 5 to 7? Well, that would be adding 2. So if the first integer, or if X is the first integer, we have to add 2 to X to get the next consecutive odd integer. So in symbols, the next integer would be X plus 2. What do we need to do now to get the next consecutive odd integer? Well, we need to add 2 to that integer, or it would be X plus 2, which is the same as X plus 4. Hopefully you can see where we're going with this. So now express the statement, the sum of the 3 consecutive odd integers is 93. So you could write it as X plus the quantity of X plus 2, because that's our second integer, and then plus the quantity of X plus 4, because that's our third odd integer, equals 93. Or X plus 2 plus X plus 4 equals 93. So again, can you think of another way to write X plus 2 plus X plus 4 equals 93? Go ahead and do that. All right, so now you are ready to do this on your own. Exercises 1 through 5 on your worksheet. Go ahead and try those on your own and then continue the video to check your answers. All right, here are the answers. Go ahead and check your answers and then continue to the next slide. All right, to wrap things up, we know how to write mathematical statements using symbolic language, or at least if we're not, I'm expecting you not to be proficient or experts at it, but at least you have a better idea as to what the process is. Written mathematical statements can be represented as more than one correct symbolic statement, so you might need some practice simplifying them, but as long as you've got the basic pieces, you are okay. We're not going to get picky about how concise they are. And we must always begin writing a symbolic statement by defining our variables or symbols. So you always start with a let statement or a suppose statement, but always pick a letter as your symbol and make sure you state precisely what it's going to represent. All right, we'll see you in class.